In this video, we are going to examine Boyle's Law. So the physical properties of a gas can be defined by four variables: the gas pressure, temperature of the gas, volume of the gas, and the number of moles of gas. What Boyle's Law shows is the relationship between the volume and the pressure of a gas. In order to analyze the relationship between volume and pressure, we have to keep the temperature constant and the number of moles constant. So what does Boyle's Law tell us? Well, it says that the volume of an ideal gas decreases proportionally as its pressure increases. So if the pressure of a gas is doubled, as you can see here, the volume will decrease by half. So this relationship can be shown here. The volume is proportional to 1 over the pressure. So as the volume is increased, the pressure must decrease. And if the volume is decreased, the pressure will increase. So why does the pressure of the gas increase as the volume decreases? Well, as the volume of our gas decreases, the gas particles are still colliding with the container, but their force, the force of their collisions, is exerted over a smaller area, which results in an increased pressure. Because we know that pressure equals the force exerted over a certain area. So if the force is maintained, if the force of their collision is constant, but we decrease the area, the pressure must go up, and vice versa. If we increase the area, then the pressure would go down. So let's take a look at some sample data here, and this data shows the volume of a gas being increased and then the pressure decreasing. So this would be some experimental data that you might get from a Boyle's Law experiment. And one thing to notice here is that if we multiply the volume from a given trial times the pressure for that trial, we get some number. And it doesn't matter what the volume and pressure are. If we multiply the two, we basically get the same number. So we get a constant value. So the pressure times the volume will give us a constant value as long as we have the same gas at constant pressure, at constant temperature, and the same number of moles. Graphically, we can express Boyle's Law as you see here. If we plot the volume of gas versus the pressure, we get a curved nonlinear or hyperbolic plot. However, if we plot the volume times 1 over the pressure, we get a straight value. So we have a constant slope when we plot the volume times 1 over the pressure, showing the relationship according to Boyle's Law. So for a given gas under two sets of conditions, again holding temperature and moles constant, we can express Boyle's Law as you see here. The initial pressure times the initial volume will be equal to the final pressure times the final volume. So this is a very useful relationship when we have to solve some problems involving Boyle's Law. So let's take a look at one such problem. If you would, pause the video and see if you can solve this problem using Boyle's Law. Okay, so the first thing I would recommend is to write down which variables we know and which ones we don't know. In this case, we're given our initial pressure, P1, our initial volume, V1, our final pressure, P2, but we don't know our final volume. We know the relationship, according to Boyle's Law, the initial pressure times initial volume equals final pressure, final volume. And so we want to solve this or rearrange this equation to solve for final volume. So that would look like this. Now all we have to do is plug in our data. Again, be sure your pressure is in the same units and your volume here is in milliliters. That's okay. We'll get our final volume in units of milliliters. So let's plug in our data. And now we just have to solve. If we solve for V final, we get 231 milliliters as our final volume. So be sure you understand the relationship demonstrated by Boyle's Law between volume and pressure. And be sure you can use that relationship to solve some problems.